Sphinx is an AI coding agent for solving data science tasks. I already installed it. It's an extension for Visual Studio Code. I have it. I have an empty notebook there and the chat application with Sphinx. And I want to give it a try. I want to use it for one of the problems we cover in our machine learning course, specifically binary classification case, where we have a telecom company with customers. Here we have some description of the customers. And then we see that this is our target variable, churn. We see that it's either yes or no. This is the variable we want to predict. And I want to give it a prompt, build a classifier for this. So that's the only thing I tell it to do. That's my entire prompt. And it's running in the agent mode, so it will now think what exactly to do. It will execute. It can create cells in the Jupyter notebook. It can take a look at the output, and based on the output, it can decide what to do next. So now it checks, it's doing the initial EDA, checks for missing data, data types, and so on, which makes sense. This is what I would do too. So it looks at what kind of features are there, or columns, like it's checking nulls or not nulls. Then there is a problem with total charges because it's not numeric, so it tries to parse it and replace missing values with something else. So it's doing some data cleaning too. So this is what every one of us would do when we deal with a new data set. We take a look at this and try to fix some problems before we can even do machine learning. So this is what it's doing right now. And also we can see it's doing some EDA for numerical variables. This is what I would totally do too. Probably I would use the same kind of graphs too, like using Seaborn. Cool. Yeah, so again, checking total charges. That's fine. So it shows the missing values. Okay. Let's see what it's actually doing. Yeah. So it cleaned it. And now it's doing again EDA, but for categorical features, we have already done this for numerical. Right now we are doing this for categorical. So this is actually how we also show it in the course. We start with the EDA, we start with data preparation, and only then we do modeling. And this is exactly what Sphinx is doing. So this is really good. And this, for me as a data scientist, it really models the way I work, so it really saves a lot of time. So we can see that, yeah, we look at the distribution of churn for different categorical variables. So here we probably see that this variable is useful for predicting churn. This maybe not so much, right? Okay, so what is it? Yeah, it's preparing the list of categorical and numerical features. Cool. And now we are already preparing to do the modeling part. So we're splitting into training and validation. Cool. So this is our training data. So let's see what it's doing right now. Yeah, so dataset has been explored, cleaned. So now we're ready to train the model. So time to build the classifier. So it decided to go with logistic regression. It's a very good choice. I would also start with logistic regression for this data set, or for probably any other data set too. Okay, so I can see that it wants to use one-hot encoder, it wants to use a column transformer, and it wants to build a pipeline, which is really amazing because this is really best practices. Using pipeline when training logistic regression. So it's really cool. Because we have some pre-processing. So we have pre-processing for categorical variables. We have pre-processing for numerical. So we have different preprocessors for them. Then we put them in a pipeline. And then we build the classifier. That's really cool. So for me, probably I would do it differently, but then at the end, I would arrive at something similar, but I will spend a lot more time, of course. And that's a very good choice for evaluating the performance of the model. I would also build a ROC curve, and actually we can see that the performance is quite good. So there was an error, but it will now fix this because it was able to look at the error, understand what's wrong, and fix it. So yeah, I don't know. I didn't have a chance to see what the error was. It was so quick to fix it. Let's see. Yeah, so the performance is still the same. It's really good. Confusion matrix also quite important to analyze the performance. And yeah, I think that's pretty much it. So it will probably do some post-training analysis. Yeah, visualizing feature coefficients to understand which features are important, which are not. I would definitely do the same thing to understand, to interpret the model, to understand what are the main predictors of somebody churning or not. Let's see. Did it? Yeah, finished writing code. And we can see that the top predicting, yeah, interesting. So contract to year, if somebody has 2 years of contract, they are less likely to churn. This is strange. If somebody is with fiber optic, then they are, yeah, okay. This is kind of strange, but okay. And this is done. The task is done. I think with that, you can see how powerful it is. So it just did all the work I would do myself for looking at the data, preparing the data set, cleaning the data set, doing initial EDA, looking at numerical features, looking at categorical features, then training the model, performing this train test split, and then finally training the model using best practices, using scikit-learn pipeline, and then analyzing the coefficients. We can, of course, do more stuff here. I can say train an XGBoost model. So now it will also, in addition to what it's done, it will train an XGBoost model, and then we can compare it. It's really convenient, so I think you see how powerful it is. So give them a try. I will include the link in the post. So check them out. And yeah, that's a really good tool. So